Hello, everyone. Welcome to another episode of ClayLovesLogic. On this channel, I solve logic-based Sudoku puzzles I find interesting. Today, I'm going to be looking at the puzzle Gaudy Geometry by Nicolas Duhail, maybe. Sorry if I pronounced that incorrectly. Um, as I said in the last video, I'm going to try to do harder puzzles and just do, one, maybe two a week. Instead of putting out one easier one-star puzzle every day, I want to focus on, doing twos and threes, maybe fours, etc. So I think this is a three-star difficulty puzzle today. As always, I'll put the link to this puzzle in the video's description so you can try it out if you'd like. But with that said, let's turn our attention to the rules. Gaudy Geometry by Nicolas Duhail. So the normal Sudoku rules apply, and we know what that means. You have to have the digits 1 to 9 in every 3 by 3 box, in every row, and of course in every column. Now we know that along green lines, adjacent digits have to differ by at least 5. These are German whispers. So for example, if this digit was a 2, this could never be, a 4 or a 5 or a 3. It would have to be at least a 7. Could be an 8, could be 9. It can be more than 5. It just has to be at least 5. And then along pink lines, digits form a consecutive sequence of digits in any order, such that, you could have 1, 2, 4, 3. They don't have to be in order, they just have to be consecutive. Those are all the rules of the puzzle. And with that, we can turn our attention to the trying to solve it. So let me just look at it for a second here. I suppose when they say geometry, I suppose he means the Fistemafell ring, doesn't he? Um, Now, there is a common, yeah, you know what? Yeah, that's probably going to be where I'm going to start. So, because there's quite a bit you can do with these closed-ended German whisper squares. So let's point this out and then let's look at the puzzle. Yeah. So okay. So let me highlight this row of digits. What can I tell you about this row of digits? Well, I can tell you that it's a complete set of the digits 1 to 9. I don't know in what order, but I know that's true. I can say the same thing about this. If we look at this highlighted region, we now have two sets of the digits 1 to 9. So I'm going to highlight a few more things here, the same color. And then I'm going to highlight these things, um, a contrasting color. Let's go with purple. Is that the right way to do this? Yeah, it is. It is. Okay, so with the tan digits, we have 5 sets of the digits 1 to 9 in any order. In the purple digits, we have 4 sets of the digits 1 to 9 in any order. So what happens if we take this digit here and we get rid of it? Well, because it's both tan and purple, the composition of these sets of digits haven't changed, right? Whatever is pink or so whatever we took out of the purple bag, we took out of the pink bag. And you know what? Let's do one thing first. Let's first of all, because purple is 4 sets of the digits 1 to 9 and tan is 5. Let's start by removing this set. Okay, so now what we have is 4 sets of the digits 1 to 9 represented by pink and 4 sets of the digits 1 to 9 represented by tan. And we know that a box has to be a complete set of the digits 1 to 9, so we can just get rid of that. But now this cell here, I don't know what number this is. Say it was a 2, 3, 4, it doesn't matter. What happens is if we remove it, we've now removed it from both. So now we have 4 sets of the digits 1 to 9 less one digit. But that digit was the same in both, so we can remove it. We can remove all of these digits that have two highlighted sets. And what we're left with an equality that you will see in every Sudoku puzzle where these tan digits are the exact same set of digits as these purple digits. It's called the Fistemafell ring, a really excellent setter, puzzle maker, Fistemafell, figured this out, pointed it out, and it's a really interesting piece of geometry. And so why I think that's going to be important for this puzzle is because these digits here, so on a German whisper, there's a couple things we know, right? You can't have a 5 on a German whisper because what would you put on either side of it? Well, if you had 5, you get 10, and if you subtract 5, you get 0, neither of which are valid Sudoku digits. So you can't have 5s on these, which means none of these digits will be a 5. The next point I'm going to make is if you put there's a couple digits in German whispers that are monogamous, and what I mean is they only have one friend. So if you think about a 6, well, if you subtract 5, you get 1. If you add 5, you get 11. So you can only subtract. So 6 can only be friendly with 1. The same thing could be said about 4, right? You can add 5 to get 9, but you can't subtract 5 from 4 to get anything that's valid in a Sudoku. So when these digits are closed off, they don't have a start. This one here could be a 6 because you could have 6, 1, 7, 2, 8, or whatever. It's fine. But when you have this composition, you can't put a 6 anywhere on here because it would have to have two ones on either side, and those are in the same box. It's not permissible. And the flip of that is also 4s, right? You'd have to have two 9s. So there's actually a little bit we know in that this composition of digits doesn't have any 4s, 5s, or 6s on it. And that's already very interesting. So I'm not sure exactly where I want to go with this. Well, I know the next thing I know is that all of these German whispers will have to have two low digits and two high digits. So these ranges here could not be fully one set. We could not have 1, 2, 3, 4 here. We could not have 6, 7, 8, 9 in any, because then we'll never have a low digit or a high digit, right? If this was 6, 7, 8, 9, well, that is a correct Renban. You don't have any high digits to put here. So because you don't have that, all of these intersect 5s. So all of these will have a 5 somewhere on them. Now, the next thing we can know is that there are no 5s in these cells. So then there are no 5s in these cells. That is true. So what about 6s? We know, we actually only have a few spots we can put 6s, and that's true. Um, okay, so both of these sets of Ren bands. Oh, it doesn't have to have a 6. It could be 3, 4, 3, 4, 5. Actually, it does have to have a 6, because if it didn't have a 6, it would be 2, 3, 4, 5. And if it was 2, 3, 4, 5, you can only have one low digit on here. So in fact, all of these have 6s on them. So that could not be a 6. We have to have a 6 somewhere here. We have to have a 6 somewhere here. Again, remember, we can't put 6s on anywhere on here, because that would form a need to have a 6 on one of these, which we've established we can't. And now 5, 6, 7, 8. Well, we're going to have the same problem with the digit 4, aren't we? Such that if you don't put a 4 on this, and 5 is the lowest digit, it goes 5, 6, 7, 8, and then you can only put a 9 on your high digit. So actually, these digits here, everywhere that they exist, for the inner ring here, are 4, 5, 6 triplets. Those are 4, 5, 6 triples. So these digits can only be 3 or 7, right? Some of these will be 3, 4, 5, 6. Some of these will be 4, 5, 6, 7. Yeah, that's interesting. Um, and that makes sense. So let's maybe pencil in some 5s. And this is where I'm afraid that things are going to slow down a bit for me. Um, I don't want to pencil all those 5s in. This is where I think things are going to slow down a little bit for me. So let's just think. Um, um, actually, um, okay. This, excuse me, sorry. I think this row might be interesting for a second, and let me just think about it, because this row has one digit currently that is of 4, 5, and 6. These two can't be. These two can't be. And this one can't be because we have a 4, 5, 6 triple in this box. So that means in these four squares, we need three that are of the digits 4, 5, and 6. So what I want to point out about that is you cannot have a 5 on a German whisper. So if this is the 5, then you'd have to have 4 and 6 beside each other, which doesn't work. And what that means is this needs to be a 5. And let's imagine that well, it just does. It just does, right? We can see you can't put 4, 5, 6 anywhere on the ring. You can't put 4, 5, and 6 here because this is a 4, 5, 6 triple that already exists. So you have four cells with which you could place the digits 4, 5, and 6. All three of them have to be in these four spaces. So if this is a 5, what are you? Oh, that's not true. That's not true. That's not true. Um, yeah, I almost made a big mistake in my thinking. This could easily be a 6. 4, 9, 5. This could be a 5. You could have 4, whatever. And then this is your 6. So all we've established actually is that this cell here is also a 4, 5, 6 triple. And then this digit here couldn't be a 4 or a 6 because you'd have to have the same, again, the same logic. If this is a 4, you have two nines. So what we know is this is either 4 or 6, and that makes this either 1 or 9. Not interesting yet, but it is accurate. So maybe let's examine that further, right? Here we have three of the digits, or two of the 4, 5, 6s. We need one more digit that's 4, 5, or 6. We know it's not here because again, we would have to have, they would have to flank. So one of these is going to be from 4, 5, and 6. I don't know which one yet. I'm not going to pencil mark it further. Is there any trick like that I can do over here? I don't believe there is. Well, you know what? We can actually, oops, sorry. We can actually just clean this up and they're 3, 7 pairs. Yeah, so that's fine. And then, so we need 1, 2, 1, 2, 8, and 9. That's all that's left across this row, at least 1, 2, 8, and 9. What do we do with that information just yet? 8 would force. Well, yeah, I don't know. I don't know. I'm thinking about that. I suppose the same thing is true here, though. This is a 1, 2, 8, 9. This is not going to be 4, 5, or 6. So this, but then 3 or 7 can fit in here. So all of a sudden, this could be any sorts of thing. The same logic here, isn't it? Is that we have a 1, 2, 8, 9. And the same logic applies here that we have a 1, 2, 8, 9. And now, okay, now that's interesting because we filled in all of the digits on the ring, right? We know the composition of them. So we're going to have, if this is a 3, this is a 7, this is a 3, this is a 7. So we're going to have 2 3s and 2 7s in the ring, these outer rings, 2 3s and 2 7s. And then we're going to have a conglomerate of other digits. And I suppose, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 other digits that are of the 1, 2, 8s, and 9s. I don't know what that is telling us yet, but maybe let's think about how this Renban can play into it because we might be able to do a couple of things. 9, 8, 7, 6. And then we still have one of the 4, 5, 6. Okay. Possibly not. Um, huh. Okay. So we have this ring figured out. And I think I'm now going to get rid of the coloring. And I think I'm going to start coloring some of these digits because I want to think about it. Maybe I won't. Yeah, let's do that. I want to think about it in a slightly different way. So we know that's true. This digit here, whether it's 3 or 7, it's light blue. This digit, it's the opposite, so we can give it a different color. But what I want to point out is, given what we know about the Fistamafel ring, we know that these blue digits have to appear on these rings, so they have to appear on these ones. Conversely, these have to appear on these ones. Now, is that even remotely helpful? And is it better than when I had the ring highlighted? I mean, the thing about it is, if this is a 3, then the composition of these becomes, well, 3 and 8, 9. Ellie, Ellie, hey, miss. Sorry, my dog is looking out the window as one does. World to see. Okay, what I want to say is, if the blue digit's 3, its composite German whispers have to include 8 and 9. Ellie, enough. Hey. Sorry, everybody. Bear with me. Ellie, come here. Come here. And conversely, what I want to say about the 7s is the low digit for the 7 has to have 1 and 2. So I'm wondering if we can start to use that logic to get rid of or have a better idea of what goes on the ring or not. And I think we can, but you know what? I think this coloring method is not better. I'm gonna just undo this back to the ring color. Yeah, I like that more for now. But what I wanted to say is, because there's 2 3s, that means we have 3 will be flanked by an 8 and a 9. 3 will be flanked by an 8 and a 9. So certainly 8, 9, 8, 9. Let me just I just want to write this out for a second. We have a 3. So what do we know about these outsides? I'm gonna use one of these. Each box in here is gonna represent what we know about one of these rings. So we could say this is this one, this is this one, whatever. It doesn't matter for now. I just want to think, because we'll have 2 7s, and the 7s have to have the low digits 1 and 2. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know 12 of these 16 digits. And then if we have an 8 and a 9 here, and an 8 and a 9 here, 8, 9, 8, 9, well, 8, 9, 8, 9. Sorry, I realize I've stopped talking. I'm just trying to think if I can get any other immediate thought about this. 8, 9, 8, 9, 8, 9, 8, 9. 1, 2, 1, 2. Sorry. 8, 9, 8, 9. 1, 2, 1, 2. 3, 7, 3, 7. The remaining 4 digits are all 1, 2, 8, and 9. So there will just be one more of those, if this one has a 1 in it, this one has a 2. If this one has an 8, this one has a 9. Um, don't know what to do about that yet. You know, okay. I suppose, well, what about this digit here? Where does this digit live? because this digit needs to be, well, it's not on this one. It's not up there. I don't know just yet. Uh, and then why? Oh, well, I mean, that's not six at least. Why given six? Am I meant to be able to? Let me. I'm really struggling here with this, actually. Just entertain me for a minute. Ellie, enough. Hey, miss, I'm gonna highlight my fours, fives, and sixes quick and see if I can. I mean, that forces this to be yellow because these will be green and orange. Ellie, sorry, I'm just gonna pause this for 1 second. Oh, that didn't pause the recording, that paused the screen sharing. Um, okay, we're back. And where were we? Where were we getting with this? Um, I'm not really sure yet. Not really sure. I mean, this is green-orange pair, right? Because it sees yellow. Okay, so that makes this yellow. And what does that really, I mean, it doesn't really tell us anything yet. I mean, one of these is green and one of these is yellow, but yellow green. I mean, and then one of these would have to be orange. Ow. Uh, but I mean, oh, well, this is yellow definitively. So this is a 4, 5, 6. That is true. And then actually, this one here needs to be a 4, 5, 6, and it needs to be orange or green. Of course, this, yellow. So yellow's not six actually, because it sees this six here. Wait. Oh, whoops. I want to deselect these ones. It's just yellow that can't be six. Okay. So now what? Now, this is going to be either green or orange. We know that. Don't know which one yet. But that means we need a yellow digit somewhere in here. So actually, this is not 5 because the yellow digit then has to be somewhere down here. Don't know where, but somewhere down there, there is a yellow digit. Conversely, we're going to have both a yellow and a green-orange digit somewhere in here. Two of them in this cell will be that. And then, we really don't know much about the middle digits yet. Ellie, enough. Get a toy. Enough. Boy, this is a real puzzle to look at. I'm sure there's a much easier way to figure this out. 9, 6, 7, 8, 9, 1, 2, 2, 3, 4, 5. If this is on there, I wish we could say for sure if this was on there or not. Is there something else to be said about 1, 2, 8, 9? Um, well, enough, enough, enough. Get a toy. Ugh. Hey, stop it. Get a toy to play with. Find a toy. Don't bark. Find a toy. Jeez. Um, the point I'm trying to make is this line here will include 19. Okay. There's a point here where the other digit that's 1, 2, 8, or 9 has to be on this red band somewhere. Because if this was 2, and this was 1, 8. Oh, that's not the case. This could be 8, 7, 6, 5. Enough. Okay. Hmm. Ellie, stop it. Sorry, I'm going to pause this for a second and let her outside. All right, we're back. And we're going to click train while we solve this puzzle. Train my barking dog. Come here. Come on. Good. All right, everybody. Let's continue to meander about this puzzle. Think about it. Into the bed. Come on. Hey, lay down in the bed. All the way in. Hey, lay down in here. I didn't have to treat you. Just go in. Lay down. Okay, great. So well, we can take this 3, 7 one step further. Uh, in the sense that, whoops, in the sense that, well, you know, 4, 5, 6, 1, 2, 8, 9. There has to be the A digit in one of these places. And the A digit has to be in one of these places. Right? Because if we look at, well, actually, I don't know that about that, but I do know about this one. Because if we look about, we look at this, we know what all these digits are, and we can't have A there. So there is an A in one of two positions. And what else does that tell us? A is either 3 or 7. Oh, of course, this is not 5. Oh, and then, hey, into your bed. Come on. Hey, into your bed. Don't bark. Sit down. Hey, Ellie, sit down. Sit. Yep. The same thing applies. If this is 4, 6, this is 1, 9. That's all true. So these composition of digits has to be 1, 2, 8, 9, 4, 5, 6, whatever, etc. But again, then the question is, none of them can be A. So whatever the A digit is, it needs to be somewhere over here. And that means this is not an A, and we have a digit that is worth. So basically, once I place a digit in both of these, in both the ring and the outskirts of the puzzle, I remove the coloring. To sort of say, like, we've removed that one from the basket. Now the same in your bed. Sit down in your bed. Girl. Okay. So the same logic now applies with B, doesn't it? None of these are B, which means B has to be somewhere over here. And then because of that, well, Well, is that wrong? No, it was right. It was right. It was under the assumption of where do you put the A digit in this column? So where do you put the B digit in this row? Well, you don't put it in any of those places. You don't put it there. So you have to put the B in one of two digits, one of two positions there. And now what do we say about A? Right? In. Well, we have A and A there. What about B now? We can't quite do the same trick because of this line, but can we isolate B in here? Because remember, we'll need to have one more A somewhere, and it's going to have to be over here. And then we'll need to have one more B, and it has to be somewhere over there. But can we do better than that? In this line of digits, where do you put a B? You don't put it here. You don't put it anywhere here. So you can go slightly better and to say that one of those has to be a B. Now, what about here? A is 3 or 7. It's less helpful on this side of the puzzle. Uh, well, you know what? This set of digits here, 1, 2, 8, 9, 4, 5, 6. So this is a 3, 7 plus 5, 4, or 6. Lay in your bed. Hey, lay in your bed. Okay, sit in your bed. No, in your bed, sit. Okay, you go in there. Sit. Oh, having fun training my puppy while I solve this puzzle. Okay, now B. Well, B now has to be somewhere in the middle. Oh, and so does A. So we have that same kind of geometry we've seen here, except this triple is orange and AB. This triple is AB, and I don't know what color. I wonder if it's orange as well. I wonder if there's a way to figure that out. Not sure. Now, yeah, it's gets gets less interesting. I'm not exactly sure what to pull from next here. AB, and I should take that pencil or that corner mark 5 out of here. That's into your bed. Lay in your bed. All the way in your bed. Sit. All right. Now, how was I able to do that? And why can't I place the B here? What was the logic? A had to be in one of those two, and then it also had to be in the middle. Well, what does that mean about B? All the way in your bed? Um, all the way up into your bed, please. Sit. Good. Okay. Um, okay, well, if we look at this column of the puzzle now, this is 4, 5, 6, 3, and 7. So these digits are always 1, 2, 8, and 9. Actually, 1, 2, 1, 2, 8. Okay. Therefore, this is also 1, 2, 8, 9. This is then 3 or oh, that's not right. Is it 1, 2, 8, 9, 3, 7? How is that? Oh, it is. Yeah, it is. Yeah, because this digit here then, um, yeah. Okay. 1, 2, 8, 9, and B. 1, 2. Okay. Whoop. No. Into your bed. Lay down. Lay down all the way. Lay down fully, okay? Okay. Wow, 38 minutes in. What happens when you try puzzles that are too hard for you? Boy, is it fun. I hope it's fun to listen to, even though I'm training my dog. Into your bed. Come on, lay in your bed. No, in your bed. That's where I want you to be. All the way into your bed, please. Good girl. Okay. So this is a Rust AB triple. I don't know what that means. Into your bed. 4, 5, 6, 1, 2, 8. Yeah, I mean 4, 5. So, oh boy, this is a 6. Into your bed. Come on, into your bed. This is a 6. That's been available for ages. Where do you put a 6 here otherwise? This just has to be a 6. I mean, we could see that these are only 4 and 5. Wow. Geez, that's been available for so long. Oh man. Boy, I feel silly. Okay, well, we have another digit. So we always have a 6 somewhere up here now, which means one of these is, which we already knew. So okay, well, now we're actually getting somewhere and we get a color because now the logic is, wait, no, that's not right. That's not right. There's nothing stopping this from being a 6. That was going to be really powerful. In your bed, please. Sit. Sit. Okay. So what can I say now? One of these is 6. We could still have a 6 here. 4, 9. All the way in. Sit down. Okay. Okay. I almost think I want to scrap all the coloring and start coloring high and low for geometry purposes. Is that why this is called Gaudy geometry? Because you have to do so much random coloring and you approach it from so many different strategies. Because what I'm trying to get at, and I don't know if this is even half of a relevant thought, but basically, um, I mean, okay, look, the Fistamafel colors have served their purpose. Let's just get rid of them. These colors have served their purpose. And then what do we have? We're coloring some yellows, some greens. Let's get rid of all these colors and let's just start coloring things, whether they can be high or low. I don't even know if this is gonna be right, but let's go, let's alternate polarity with blue and tan. So if this digit's low, this digit's high. If this digit is high, this digit's low. If this digit's high, etc., so on and so forth. And we get to a point where then we can say that this digit here, you know, there's 4 digits that are low, 4 digits that are high. 1, 2, 8, 9. This has to be, well, yeah, this has to be that polarity, right? Is that right? That might not be right. One second. Get your bed. Sit down in your bed. Well, actually, it is for 1, 2, 8, 9, isn't it? Because there's 4 digits, 1, 2, 8, and 9. Two of them are low, two of them are high. So of these four digits that represent 1, 2, 8, and 9, if we have two that are tan, we have to have two that are light blue. Yeah, actually, so that's a light blue digit. I don't know what one it is. 1, 2, 3, 4. So all of our high or low polarities, basically, those are sorted. Into your bed. So now, no, don't bark. Go get a toy now. Bring me a toy. Bring me a toy. Find a toy. Find a toy. Um, hey, find a toy. Enough. Find a toy. Bring me a toy. Well, actually, the trick we used here, we can now use here, right? Because we have two digits from 1, 2, 8, 9 that are low or high, whatever. They're of one sort. So two can go here. Now, the nature of German Whisper is that two of, these actually have to alternate. So is there a way that, well, these can't both be tan. So these have to be blue, actually. And this has to be tan. And now we know that the A digit, wherever we see it, is tan. It shares the same parity as the as these, which means B is blue. It's of the, higher. And what's interesting about that now is because B is here, we know that it's going to be a blue digit. What does that tell us? Well, it's going to tell us that the next digit beside it can't be blue, has to be tan, which means there's two tan digits somewhere on here and two blue digits. But what that tells us is because B is blue, the next digit beside it has to be like that. So 1, 2, 3, and 1, 2, 3. So if we look at our 1, 2, 8s and 9s, 1, 2, 8, and 9, B is blue. So the 1, 2, 8, 9 digit that's here is tan. So if we have a tan 1, 2, 8, 9 and a tan 1, 2, 8, 9, then this has to be blue. I hope that makes sense. That makes sense to me. And then what we know about that is we now have 1, 2, 3, 4 light digits and 1, 2, 3 tan digits. So one of these is tan and one of these is 5. So tan and brown, I guess. Let's use brown to /5 for this. And now, because we know that, well, what do we know? We know 1, 2, 3 digits are. Okay, I think I'm onto something here finally, 45 minutes into this puzzle. Let me just figure this out quick. Let me just figure this out quick. A brown slash for our 5s, but the point I want to make is now that we know this is 6, what can I tell you about 1, 2, 3, 4? Because basically it's going to be B is light blue. So let's just even just, I don't know which one it is for now, but let's just say that's blue because what holds true is that we're going to have something like that. I don't know what the composition is, but it'll be one way or it'll be the other. And that'll give us 1, 2, 3, 1, 2, 3, damn. And that doesn't help yet. Hey, get a toy. Get a toy. Don't chew my hand, please. Or go to your bed. Go to your bed. Come on. Into your bed. No, into your bed. Come on. Lay down into your bed. I'll give you a treat. Oh, well, don't know what I am meant to tell you about this puzzle just yet. Well, we know that. Okay, here's the next thing. Into your bed, please. Sit down. Okay, we know that B is blue, which means it's going to have to be flanked with the 1289 digit that's 10. And what that means is this 1289 digit has to be blue. 1289. So both of these are then 10. And the second that this is 10, we know that it is an A digit. None of these can be A anymore. Into your bed. And then this is blue, and this is 10. Now of our 1, 2s, 8s, and 9s, I don't know yet. Okay. Well, yeah, we do look. We have two blue 1289s. So good. Sit. Good. So we know that that's 10 because we already have two of them. So 1, 2, 8, 9. So this one's blue. Okay. Now, up here, like I said, because blue is light, or B is light blue, then we're gonna have to have a light blue, two tans, and then a pink. Doesn't help just yet. Well, I guess it's true that you have to have two blues here. Two blue. One of these is blue. How does this work with the red band? 1, 2, 3, 1, 2. I just don't know how it works yet. Into your bed. 1, 2, 3, 4. Boy, this is a tough puzzle. 2, 3, 1, 2. Do that all the way, please. All the way into your bed. Go into your bed. Um, I have an idea. Bear with me for 1 second. Just wait. Wait. I'm creating a little puzzle for my dog here. Stuffing her little bed with little treats. She'll have to. Okay, go. She'll have to nose out, and that should buy me some time to puzzle. All right. Well. Oh, well, this is A or B, but we've established that it's blue. So we know that it is in fact B. That's still true. These 1, 2, 8, 9 switch polarity, which we know. Oh, why can't I see this? This is going to be like that, isn't it? This could be like that. 6, 4, 5, 6, and A. So we know that this will be like this. So we'll have two low digits. We'll have two high digits. Man, that still doesn't help me. Like, yeah, that still doesn't help me. Boy. I guess, we have our two. Oh, okay. Well, here's an actual something that's relevant is we have two digits here that are from 1, 2, 8, 9 that are of one polarity. So this one has to be of the other at least. And now, is there a way for this to be of the other and make sense? 9, 8, 7, 6. And that would all be blue. And then these would both be 10. This would be 10. Um, what can I tell you about these rings? Don't these always alternate? If this is A, the 1, 2, 8, 9 is alternate of it, right? The corner one alternates. It does. So this is like that. Because we know that A has to be, flanked with two blues. Like that or like that, doesn't matter. But there'll be two blues, a 10. A is somewhere here. 7, 2, 3, and yeah, it could go anywhere there, really. I guess the next little tidbit is that B's anywhere there. That's not that useful though. B, 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 B. Um, A, A. I guess the question is, knowing that this is 1, 2, 8, 9, and it's of the same polarity that B is, does that mean B has to be on this? Because B is either 3 or 7. So if this is 9, 8, 7, or 2, yeah, no matter what, B is somewhere on this. That's true. And well then 3, so 3, 4, 5, 6. So A is not. But that's just like so unreasonably unhelpful. I mean, sure, we have B in one of two positions. We have A in one of three. But that just doesn't do a thing to help me. I am just like absolutely gutted at what you might do to solve this puzzle. Um, I think I'm good enough at geometry. I wonder if I could tell what this is. This one and this one will have the same, but it could be A, right? Because if this is tan, this is tan. Could this be as high as 3 or 7? If it was 2, 9, 3, 8, yeah. Okay, so this could still be A. Because the problem is A can still be in any of these places. So there is going to be a blue digit somewhere here, but it doesn't necessarily need to be. Well, actually, there you go. Look at that. We have a 1 and a 9 that's the same. So this is like that. And now both of these are blue, and that's so helpful because this can't be A anymore. Oops, we at least remove one possibility of A. But regardless, both of these are like this. And now we only have 4 digits that can be this color. And 3 of them, well, 2 of them happen to be here. We might be onto something. We might be onto something. A third of them happens here. And a fourth of them happens here. We're onto something. Look, both of these have to be blue because this one's tan. Once both of these are blue, these have to alternate. So we'll have a blue and a tan, we'll have a blue and a tan, which means A is 7, and because 6 is now 10. 6 is 10. A is 7. This is huge. Oh, this is so huge. Um, we get a number. We get a bunch of numbers. A is 7. Wow, we get a bunch of numbers. We get so many numbers. This here, this is now 6. It has to share the polarity with that, which means this is 1. And then this, oh man, this is so awesome. Okay, oh, this is so good. We finally got it. This is not, oh, well, it's just 2. It's just 2. This is an 8, 9 pair. Oh, gonna just absolutely earn this. That's 8, 9. Oh, well, B is 3. That's the flip. B is 3. These are 8, 9s. This is 4. This is no longer a 4. It's only 5 or 6. This could be, well, could be anything. One sec. Okay, just don't get ahead of yourself. Go a little slower. Take out your 8s and 9s. Take out your 1s and 2s. Take out your 8s and 9s that are here. These are now 1, 2, 3. This here, this is not 8 or 9 anymore. Oops, 8 or 9. It is 1 or 2. So it's either 2, 3, 4, 5 or 1, 2, 3, 4. So we can go in and we can say, first of all, we can get rid of B. We can just go 2, 3, 4, 5. I guess it could be 1, 2, 3, 4, 5, couldn't it? Because this could be 2, 1, 3, 4. Yeah, anything like that is fine. It's fine. Okay, so what can I tell you next? Well, this is 10. We have 2 low digits. Okay. I still don't know which one this one is, but we're gonna get pretty close. This is, well, now that this is just 8 or 9. So we have 4, 5, 6. Okay, let's just think. This one here is not 1 or 2 anymore. Oh, this is only 9, which gives us an 8, which gives us a 9, which gives us an 8, which removes the 8. 9 now has to be over here. B is 3. We know that's true. But let's just think, oh, we have a 1, 2 pair. So this is going to be 3, 3 and 8, because we need a high digit. This is 3 and 8. So we have a 1, 2, 9 triple. We have a 3, 8 pair. Okay, so 1, 2. This is not 4. We have a 4. We have a 5, 6 pair, and that is the right colors. And now what does that mean? 1, 2, 3, 4, 5, 6, 7. Okay, so this is just, 5. This is just 5, 6, 7. Yeah, that's true. And then this here, we have a 1, 2, 9, and we have 4, 5, 6, 7. This is just 4 or 5. So it is blue or 10. And this is blue or brown, sorry, and this is blue or brown. But let's think, we should be able to do better than that. 4 or 5 gives us a blue or a brown. 1, 2, 3, 4, 1, 2, 3. Not sure yet. Oh, well, the 2 sees the 1. Beautiful. And the 2 sees the 1, the 2 sees the 2. That's now a 1, 9 pair. 4, 5, 6, 7. 1, 2. Boy, 2, 2. This is 8 or 9, which is still fine. This is not, well, it's actually, we're still not sure. We're actually still not 100% sure. That's fine. A is, what was A? I actually can't remember. Well, A is 7. So there's a 7 somewhere here, and there's a 7 somewhere here. And then B is 3. Let's get rid of the lettering. There's a 3 somewhere up here. So this is, this is a 4, 5 pair. So what do we have? This is a 3, 8 pair now. Yeah, this is a 4, 5 pair. This is 3, 8. We have an 8, 9. So what are these? 1, 2. So there's always a 3 here, which we knew. 3, 3, 4, 5, right? Yeah. 3, 4, 5. Oh, look at that. A 3, 4, 5 triple, because we can't put 6 here, and we can't put 6 here. So we get a 6. We have a 4, 5 pair. We have a 3, 8 pair. This is now 2, 9. Not solvable just yet, but we know that it is 2, 9. Oh, this is awesome. This is so great. 4, 5 is, blue or brown. This is blue or brown. This is blue or brown. I don't know yet. Let's just look at the digits we have and think about what we can do. Because we have quite a few digits filled in now. We have to be able to do a little something something. Oh, well, this tan digit is not 1 or 2 anymore. That's just 8 or 9, which we knew. 189 triple. Okay, we have a 189 triple that seems to be the case. Because 2, 3, 4, 5. Yeah, that is a 1-8 triple, 189 triple. So 1 gets removed from here. This is a 2-3 pair. This is not a 3 anymore. Oh, so that's an 8. Oh, great. 8 and 3. And 8 is 10. No. Yeah, 8 is 10. 3 is light blue. Then we're going to get a 9. Oops, we went off our colors here. A 9 and a, sorry, a 9 and a 1. 9 is, of course, tan. 1 is blue. Two. Oh, this is an 8 now. Lovely. None of these have the capability to be an 8. So we have a 1, 2, 9 triple, 4, 5 pair. Okay. So ones, this is not a 1. 1, 2, 9s, 4, 5, 2, 3. So what is this? 1, 2, 3. We need 4, 5. 3 is A. Wait, A is. I can't remember if A was 3 or if B was 3. I think A was 3. Doesn't matter. The point is we have a 1, 1, 2, 3. So we have 4, 5, 7, 9, right? 4, 4, 5, 7, and 9. Yes. So let's just get rid of that. And let's just go 4, 5, 7, 9. And this is, well, this is a 7, 9 pair. So this is a 4, 5. This is a 4, 5 pair that is of that parity, polarity, whatever you want to call it. Okay, we have a 4, 5, 6 triple. We have a 7, 9 pair now. That's wrong. That's wrong. That's wrong. That's wrong. This can't be a 7, 9 pair. Let's back that up a little bit. So what were we saying here? We have 1, 2, 3, 4, 5, 7, 9. Crap. Um, 4, 5, 7, 9. Is that 1, 2, 3? Yeah. This can't be 7, 9. 1, 2, 1, 2, 3, 4, 5, 7, 9. We can't have a 4 or a 5 on here. Oh, we need to have a 4 on this. We need to have a 4 on this. It needs to be, there's a 4 here somewhere. 4, 5, and then there's a 2. There's a 2, this is a 2, 7 pair. Or no, it's not actually. It's a 2, 9 pair. Because then this has to be 3, 4, and this has to be 9. That's the only way this works. This is a 1, 8 pair. So this is 2, 9. The flip side of that is going to be the digits, well, 4, 5, 6. So it's 1, 7. And 7 now goes in the middle. Excuse me. 7 now goes in the middle. Now there is a 5 down here, isn't there? Possibly not. Possibly not. I might be getting ahead of myself. No, there is. This is a 2, 5 pair. Let's get rid of all this stuff. This is a 2, 5 pair. So we get a 4, we get a 5, we get a 4, we get a 5, we get a 4. No, we get a 6. Sorry. We remove those abilities to be 6. That's a 5, 7 pair. This is now a 6. This is a 4. This is a 5. This is a 4. This is a 3, 5 pair now. This is 3. This is a 4. This is a 5. None of these are 5s. This is a 6 by that 6. This is a 4. This is a 1 or 8 pair. What does that say? Let's not. Let's keep absolutely whipping on. We're making such excellent progress in this puzzle. I truly stared at this for a long time, not thinking I would be able to tell you anything about it or make any sort of meaningful headway. 7, 1, 2, 9. Ones are now not in any of those places. Oh, which we already knew. This is a 1, 2, 9 triple. Oh, and if that's a 1, 2, 9 triple, you can't put a 2 anywhere on this, so this has to be a 2. These can't be 2s anymore. That's a 1, 9 pair. So this has to be 2, 3, 4, 5, of which these can't be. Uh-oh. I think we got carried away because you have to put a 4 somewhere here. We got a bit carried away. Let's unwind this quick. We got carried away with ourselves. Let's go back to about here. So 1 sees this. So this is a 7. So this is a 1. So this is a 9, and this is a 2. And now the real takeaway I want to impress on you is that you can't put 4s anywhere here. And this is a 1, 2, 9. Oh, crap, we have repeat 5s. When did we get those? How far back do we have to go? We got carried away. We really flew, and I think we made a mistake. Let's unwind all this really quick. We really got carried away there. We were going so fast. Okay. So we know we need to put a, okay, let's scrap this. Let's scrap this. We know we need to put a 2 somewhere here. So the 2 has to go down here, right? We can see that. So 1, 2, 3, 4, a 5 somewhere here, 6, and a 7. 7 can't go down here. So this is a 7. This is a 2, 5 pair. That feels right. I feel like we might have made a mistake in a different way with that. This central digit might have been, no, because this is what started it. This is a 2, 5 pair. Yeah, okay, let's go slow. The 4 gives us a 5. None of these can be 5 anymore. We have a 6, 7 pair. 6, 7 pair gives us a 4, which gives us a 5, which gives us a 6, which gives us a 5. That's all well and good. We now remove the 5, and we have a 3, 4 pair. This 3, 4 pair gives us a 5 here, which gives us a 4 here, which gives us a 5 here. We get a 5 here. Okay, I think we just made an incorrect pencil mark somewhere. We were rushing. Let us change the coloring on all of our 5s to their nice, lovely browns. And let's change the coloring on all these new 6s we've added. There's only a couple, really. But I want all the 6s to be this nice tan color, and I want all the 4s to be the blues. Great. All right. So what is the next piece of this puzzle? Well, the next piece of the puzzle is that this is a 1, 2, 9 pair. That is still true, but we can back this up more appropriately. And what we can now say is that if this is a 1, 2, 9 pair, we can't have a 1 or a 2 on this. So this is a 3, 4, 5 triple, and that does require this to be a 2. That is still accurate. And now, if this is a 3, 4, 5 triple, then this has to be 6, 7, and 8. Yes, that is in fact true. This 1 still sees this 7, sees the 1, sees the 9, sees the 2. The 2 sees the 9, sees the 2, sees the 8 and the 3. 3 is a blue digit, and 8 is a tan digit. And we have 3s in the corner. Isn't that nice? It is nice. It is, actually. So this is no longer an 8. This here could not be a 5. This is 4 or 6. So 3, 4, 5, 6. Oh, and those are not 5s. So this is actually a 3, 4 pair, which is going to give us a 6, which is going to give us a 7, which is going to give us a 5 and a 4. Oh, yeah. This is great. Okay. The 7 gives us a 6. Oh, and actually, both of these, both of these are that color. whoops, uh, a 7. So where do we go from here? Well, 2's in one of the four corners. That's fine. 1, 8 or 1, 9. Um, we really are very close to being done this puzzle. What's this triple in the middle? 1, 2, 3, and a 4, I believe. And this could not be a 4. This is 1 or 3, which forces this to be 9, and it makes that be 8. Or sorry, 1 and then 8. So this is 3. So this has to be 8. It's the only option left. This is then 4, and this is 1. So this is 3, this is 4. This is 3, this is 4. This is 5, this is 2. This is now 1. So this is 4 and this is 3. This is not 7. And this is not 7. Oh, and then so that's a 6, 8 pair. And it sees the 8. This is a 6. This is an 8. We have what remaining digits? Across here, we have 1, 2, 3, 4, 5, 6, 7. 1 second. I have to. Okay, sorry, we're back. 1, 2, 7. This is not 1 or 7 via Sudoku. So we get a 2, we get a 1, we get a 2, we get a 7. Last remaining digits. 8 sees the 9, sees the 8. 1, 2, 3, 4. We need a 5 somewhere. Not there, not there. This is a 5. We need a 6, which is here. And finally, we need a 9, which is there. Wow. 74 minutes and 34 seconds. 118 people have solved this puzzle in 20.2 days. I really did enjoy this puzzle. Nicolas Duhail. It took me quite a while to break in. I really wasn't sure where to go with that. Yeah, first I had the Fistamafel approach, and then the coloring the fours, fives, and sixes, and then finally coloring the the parody of the German whispers to try and get a crack on, and finally, coloring the ones, twos, eights, and nines was really the thing that did it. Boy, that was a tough puzzle. Very, very fun though. Great puzzle. Thanks everyone for watching, and I hope you enjoyed it. Again, if you have puzzles you'd like me to try, put them in the comments or let me know. Um, and yeah, see you on the next one. Thanks, everyone.